So last year, Phil Darrow did an Ignite, and it inspired me to think about ways in which we try to make math memorable for our students. And my first story is going to come from my own classroom. I was teaching Algebra 2 for the first time, and we were looking at families of functions, and I was teaching domain and range using parent functions, and I anticipated that this notation would be challenging for my students because there are so many symbols. And sure enough, the student said, "Miss DeCarli, does the alligator eat the bigger number or the smaller number?" So I posed an open-ended question. And my students explained to me that the alligator is a visual mnemonic that helped them remember that the open end is like the open mouth of an alligator, always wanting to eat the bigger number. And I like the alligator as a visual mnemonic because it's pretty simple and it kind of relates to the mathematical meaning. But I think when we get to this level of mathematics, it gets a little bit confusing and students start to ask perplexing questions like, what does it mean to eat infinity? So the Common Core tells us that in grade 1, students are going to compare two two-digit numbers using the symbols greater than, equal, and less than. It seems like at grade 1, the alligator is an appropriate mnemonic to use. The next one is a little bit complicated. It's a visual and narrative mnemonic. So a fraction is like a house with an upstairs and a downstairs. And in that fraction house, there's a fraction upstairs and a fraction downstairs. So we're talking about division of a fraction by a fraction. I'm going to narrate the video, but I had to speed it up a lot, so pay attention. Okay, so there's a fraction on the downstairs, and he wants to go upstairs, but he can't fit through that space. So he has to do a somersault up the stairs. Multiply across the denominators, and you get the answer fraction. I have so many questions. Can you really do a somersault upstairs? Unfortunately, none of my questions have anything to do with fractions or division or the division of fractions. I don't need to bash the teacher who created that video. She's super creative. I bet she really, really cares about her students and really wants them to remember how to divide a fraction by a fraction. She just got a little carried away with her story there. I'd like you to read this. So if we're going for the second kind of student, a student who can explain where a mnemonic comes from, a student who thinks that mathematics makes sense, then I would like you to consider that perhaps Googling free fraction lessons is not the best way to build our curriculum. Okay, the Common Core tells us that in grade 6, students solve problems involving division of fractions by fractions by using visual fraction models. And visual fraction models, that phrase comes up over and over again in California Common Core, and in about 45 seconds I'm going to try to show you one. But first, the butterfly method. Phil Darrow mentioned this last year and I had never heard of it, so I Googled it. And it's a mnemonic for remembering how to add or subtract fractions. But I'm not the best person to explain it to you. There's two girls I'm going to introduce you to. They're called the Fierce Math Chicas 1, 2, 3. And they love math so much that they have a YouTube channel where they explain math. And they've had over 5,700 views, and they claim to be 21, but they are not. So I have anonymized them in the following video clip.
2 times 7 to get the denominator. So make your long little loops to make it look like a butterfly. See, isn't it a butterfly? That's why I call it that. So our answer is 24/14ths, which can be simple.
We'll see the rest right here. So the Fierce Math Chicas 1, 2, 3 love math. They're really good at procedures. They just didn't realize that they were applying the butterfly method to the wrong kind of fraction problem. The Common Core tells us that in grade 5, students will represent fraction products as rectangular areas. And I'm going to attempt to show you my interpretation of that in the next 30 seconds. So we're going to start with a whole rectangle divided up into 7 strip sheets, 6 of them to represent 6 sevenths. And now I'm going to divide horizontally into 4 congruent strips. So now I have 24/28. Those are equivalent fractions because it's the same part of the same hole, same area there, but I only want 2/4 of my 6 sevenths. So I'm going to take 2 of those 4 rows and shade those, and that's actually my answer, 12/28. And if we had more time, I would show you how we could rearrange those squares to show that that's equivalent to 3 of my original sevenths. Sorry, not really enough time to do justice to that. Okay, so lessons from this presentation. Meaningful representations are greater than cute mnemonics. The next one is really hard to say fast, so just read it. And 15 seconds go really quickly, so good luck to